Okay, so when you're asked about the angle between bonds in a molecule, of course, you've got to draw the molecule first. So you've got to draw the Lewis structure first, work out its electron group geometry, therefore its molecular geometry, etc. And I believe this is just asking us for ideal bond angles, okay? So that is just going to be based on the geometry, whether it is trigonal planar or the angle is going to be 120, for example. In tetrahedral, the angles are going to be 109.5, etc., etc. So we have phosgene, so carbon has got 4 valence electrons, oxygen's got 6, and we've got 2 chlorine, so 2 times 7 is going to be 24 valence electrons. So my central atom is going to be carbon, because carbon has got a bonding capacity of 4, right? And oxygen's only got a bonding capacity of 2, and chlorine's only got a bonding capacity of 1. So I'm going to make it look kind of symmetrical, join them up with single bonds, and see where we are at. One single bond, one single bond, one single bond, like so. All right, so give chlorine and oxygen their lone pairs of electrons. I'm going to go fairly quick on this one, as quick as I can with trackpad mouse. All right, so how many electrons do we have? 2, 4, 6, 8, 10, 12, 14, 16. Right. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. All right. So don't be tempted to do anything silly like putting lone pairs on the central carbon or anything. We've got 24 valence electrons and we are okay. However, carbon does not have a complete octet. So what are we going to do? We're going to have to convert a lone pair to a bonding pair. So I choose you, oxygen. Why? Because chlorine doesn't want to do it. So we're going to convert that lone pair into a bonding pair, which is going to give you a double bond between the carbon and the oxygen. So hopefully I've done these that I can actually kind of sort of I'll put the O back in. There we go. Oxygen in here and convert that to a double bond. So remember when we're calculating our steric number for our electron group geometry, it doesn't matter if it's a single, double, or triple bond. So my steric number is going to be 3 bonded atoms, no lone pairs on the central atom. So steric number of 3, that tells me my electron group geometry is trigonal planar. Okay, so what is my molecular geometry? Well, in this case, there's no lone pairs on the central atom. So my molecular geometry is also trigonal planar, and the ideal bond angle there is 120 degrees. Okay, so when it's talking about the carbon-chlorine bonds, you can just see, I'll highlight those for you real quick so you know what I'm talking about. The carbon-chlorine bond would be this bond angle here. So another way of writing that is like the Cl bond, okay? And I know how I've drawn it in the Lewis structure looks like it's linear, but it's not. If we were going to like redraw that with the actual bond angle, you've got to remember that Lewis structures only tell you what is bonded to what. It doesn't tell you like the shape of the molecule. You've got to work that out with VSEPR. So a more accurate looking way of drawing that would be with that double bond there. Oh, it's green. Whoops. That double bond there. And these would be single bonds, and that bond angle would be 120 degrees. Still doesn't look perfect, but you get the idea. Okay.